All right, y'all, we are doing 7.4 notes. Now, I know some of you may have seen these notes already, but some of you may not. So I'm going to make a video just kind of going over the problems in the 7.4 notes. So you should be able to complete your note packets by watching this video. So first off, start off with a warm-up question. We have a restaurant that needs to build a wheelchair ramp for its customers. The angle of elevation for a ramp is recommended to be 5 degrees. If the vertical distance from the sidewalk to the front door is 2 feet, what is the horizontal distance that the ramp will take up? X, which is X, and then how long will the ramp be? How long will the actual ramp be? That's Y right here. It says round your answers to the nearest tenth. And so going over here, going to my pen. So again, essentially what we're trying to find side lengths here. So we're trying to find the side length X and the side length Y. All right. So knowing that, I know I'm going to be using my trig ratios, either sine, cosine, or tangent. All right. My angle is 5, so I'm going to use this angle. I'm going to go ahead and label all of my sides. I got my opposite side, my adjacent side, and then y is my hypotenuse. All right. So let us find x. All right. So when I'm looking at x, I notice that it is the adjacent side. Then I also know that I know my opposite side as well, so I can use the trig ratio that deals with opposite and adjacent, which is tangent. Again, tangent is opposite over adjacent. Again, remember SOHCAHTOA. So we'll do tangent of 5. Again, our regular trig. We use the angle, the measurement of the angle. So 5 degrees is equal to, and again, tangent is opposite over adjacent. Opposite is 2, and adjacent is x. And then to solve for x, what we would do for this is, again, treat tangent of 5, put that over 1, treat it as a big fraction. You do your cross multiplication, you get x times tangent of 5 is equal to 2. You want us, again, we're trying to solve for x. You divide tangent of 5 on both sides. And you would get 2 divided by tangent of 5. Which if you solve for that, it will get you x is equal to 22.86 degrees. I mean 86 feet, my bad. All right, so that's x right here. We've solved for this one. Now we need to solve for y. We need to solve for our hypotenuse. So again, I'm going on the 5-degree angle. If you would want to, you can use the angle up here. We know these two angles, so we know what this angle is. If you'd want to use this angle up here, you can. However, you would also need to readjust your opposite adjacent sides. Your hypotenuse is always your hypotenuse, but again, you'd have to just recognize what is your opposite and what's your adjacent. All right. So again, I'm going to go again from the 5 degrees here. I'm just gonna erase this angle here. Just kind of erase some of this stuff here. So I'm gonna go from the 5 degrees. Oh, the 5-degree angle there. And if again I'm trying to solve for y, I already know my opposite side, and I know my hypotenuse. Now we did find our x, we found our adjacent side. However, anytime that we're trying to find side lengths, I would say always use your your first known side. So you can use the 22.86 as this x right here. However, I feel like, for a more precise answer, you should use the 2 feet right here. Again, you can use this x. However, I feel like the answer will be a bit more correct if you use your already known. So I would say use your known value when doing all of your computations. All right, so trying to solve for y here, and we know our 2 feet here. Let's see, 5 degrees, our 2 feet is again our opposite side, and now we're trying to use our hypotenuse. Got to think of again, we're trying to find a side length, so we need to use a trig ratio that deals in terms of opposite and hypotenuse. You should know by now that is sine, so what we can do is we'll do sine of 5 degrees, again, angle and sine, again, sine of our angle. That's a 5, I apologize for my terrible handwriting. So sine of 5 is equal to, again, opposite over hypotenuse, or opposite is 2, and our hypotenuse is y. And then kind of the same process up here, you would set sine of 5 over 1, do your cross multiplication. After all is said and done, you should get y is equal to 2 over the sine of 5, which if you solve for that, it would get you 22.95 degrees. I mean feet. I'm sorry about that. It's feet. Keep getting them mixed up here. All right, so that is the warm-up problem. So probably the only bits of notes, the rest of the, I think as a lot of you can see, the rest of the problems on the 7.4 notes are actually just example problems, but for notes, and again, this is real important for being able to solve these word problems that we're going to be looking at. So 2 terms that we wanted that we're looking at here: angle of elevation and then angle of depression. Now the angle of elevation here, as we can see, that's essentially the angle measured from the horizon, which is again this just this straight line right here, in your line of sight, which is your eyes, and then it's the angle when you look up. So it's essentially, if you look up, if you have a straight line looking out right here, and you look up at this line right here, the angle of elevation is essentially this angle measurement right here. Okay. And then the angle of depression, the angle from the horizon, again, the straight line, just a straight line across, to your line of sight looking down. So this is your line of sight here, looking down, and this is the horizon line. And the angle of depression is essentially this angle that is created right here when you look down. Angle of elevation is when you look up. Angle of depression is when you look down. Make sure that you get this down, you know it, you understand it. That angle of elevation is always looking up, and angle of depression is always looking down. All right, so another example here. You got a math student that is standing 25 feet from the base of the Washington Monument. The angle of elevation from her horizontal line of sight is 87.4 degrees, and her eye height is 5 feet. Excuse me. How tall is the monument? So let's draw a couple pictures here. It says draw a picture, and again, any word problems, not only for this class, but any word problem, math problems that you have, draw pictures. So let's see here. So we have our monument here. That is our unknown. So I'm going to call that X. All right. And you have a math student that is standing 25 feet away. Okay. And it says that our eye height, so I'm going to draw this, is 5 feet. Okay. See, if her their horizontal line of sight is 87.4 degrees. So I'm going to draw her horizontal line of sight, kind of in a not a good dotted line there. And then her line of sight would be 87.4 degrees. So right here, we know that this angle here is 87.4 degrees. And also the 25 feet from the base, I forgot to put that in as well. So if we look here, basically from her horizontal line of sight to the monument, and then essentially her line of sight, we can see that it is just one big right triangle. And from that, we should be able to use trigonometry in order to find out this missing side length. However, one thing we also have to keep in mind is the 5 feet of her eye height, because again, her eye height is 5 feet above the ground, and her horizontal line of sight is at her eyes. So that's going to come into play a little bit later. So let us do a little bit of trig here. So let's see here, 87.4 degrees. I'm trying to find a side length, so I'm dealing with my regular trig ratios. I know my 25 feet, and I need to find my x. So let's label these. So going off of the 87.4 degrees angle, my x is going to be my opposite. Again, it's the one that's opposite of the angle. It's not touching the angle at all. And then 25 feet, that's my adjacent. And then don't really need to label the hypotenuse up here, so we're not going to worry about that. So let us solve for this x value right here. So solve for this x value. Again, what is a ratio that deals in terms of opposite and adjacent? That would be tangent, all right? So we'll do tangent of our angle. Our angle is 87.4 degrees. Again, tangent is opposite over adjacent, so it is x over 25. If we want to solve for x, we would just multiply the 25 on both sides. Cancels on this side. Multiply 25 by tangent of 87.4. And again, I'll rewrite it over here as well. So I'm going to send the page. So we have x is equal to 25 times the tangent of 87.4. If you solve that out, solve for tangent of 87.4 and multiply that by 25, you should get x is equal to 550.5 feet. Now, one thing you should notice is that that is not our final answer. Now, because again, if you look up here, solving for this x only solves for this height right here. This doesn't take into account the height from her eyes to the ground. And if it asks us how tall the monument is, we're trying to find the total height from the ground all the way to the top here. So if we know that this is 550 right here, and this is 5, to find the total height of the monument, we would just take x plus 5. So it would be 550 plus 5, in which the total height, I'm going to write it over here. Total height would be 555.5. All right. So again, looking back at this one again, so the key thing is that her eye height is 5 feet above the ground. Okay. Eye height is 5 feet above the ground. And then when we do the triangle that is based on her eyesight, we have to know that her horizontal line of sight and her angle of elevation, 87.4 degrees, that creates a triangle that is still 5 feet above the ground. And then when we solve for the missing side length over there, we only get the part, the 550 feet that is above that 5 feet that's above the ground. And so because we need to find the total height, again, the height from the ground to the top, and we only know that the height from her eyesight to the top, we just add in that 5 feet to get the 555.5 feet. All right. So I'm going to stop this recording, and then I'm going to record another video that goes over the final 2 examples from the notes.